Hi, welcome on stage.
Hello. Hi, can you hear me?
To see you. I can hear you and I can see you very well. So,
Great.
Alexandre is with J.A.M.E.S GmbH, and he'll be telling us about accelerating the development of AME, additively manufactured electronics. So, welcome, and the stage is yours, and you have 20 minutes. So, good luck.
So, yeah, my name is Alex. I'm the business development manager of J.A.M.E.S, and J.A.M.E.S means jetted additively manufactured electronic sources. But no worries, you don't need to remember that in detail. Please keep in mind, J.A.M.E.S is the point of contact for 3D printed electronics. And today I will give you more insights into our activities and what we are providing in this field. So, as you maybe know, we will have more or less a linear market growth during the next 10 years in the field of printed electronics. And the question is how we can come to a more exponential growth or unlock a higher volume earlier for all of us. So how can we increase the speed of the market development? So that's a question we have. So, and this is what we are doing at J.A.M.E.S. So as you know, the new technologies need education to grow the market. And time is the most valuable thing we all have. Searching the web for information takes too much time, and there's a high risk of missing information. So that's the reason why we build up a platform for the 3D printed electronics community. And that means we bring the whole ecosystem together and becoming point of contact for all the information out there. But let's take one step back and talking about the E in AME, additively manufactured electronics, so that we have the same understanding of what AME means to us as J.A.M.E.S. So AM, so the additively manufacturing, is developed over the last years. We have a lot of processes, you have a lot of different materials there, and it's often only focused on mechanical requirements. It's driven by mechanics and optimized for lightweight or heat resistance, for example. The next step is when you're adding some electronical or electrical requirements to that. This means every electrification of existing surfaces or of existing structures, like antennas or thermal radiation, for example. So print on flexible PCB or molded interconnected devices, so that they called MID structures. And we are saying in our wording, this is 2.5D in our meaning, but this step in between is necessary to come to the real three-dimensional structures. And this is what we want to achieve, the combination of mechanical and electrical requirements. We want to have embedded components. We want to have free 3D wiring. We want to replace components like capacitors, for example. I will show you something later on. And this is what we want to have, fully 3D designs. And I would like to show you some examples to make it more clear in this case. So here you can see an example. This is called PLL cube, and PLL means phase locked loop, or easier, it's an RF generator. In this case, it's around 1090 megahertz, I think. So this application gives you a first idea where it can go to. So we can also overcome mechanical issues. For example, you can increase the stability by filling up any available volume with electronics or dielectric material in this case. So in comparison to that, the traditional PCB of this application is much larger than that small and compact cube. And for sure, it's much easier to break in this case. Another awesome application, what I want to show you, is our 3D printed drone. So this example shows very good advantages of AME. So by the way, this application is a great eye catcher on every event or exhibition. All the people are stopping at our booth when they see this drone, and then we get in discussions about this technology. So this is quite nice to have